We have all been there when working with details, desperately trying to make our assets fit, getting lost within piles of arrays just to discover that instances are not always a viable option, and painfully having to rebuild all again from scratch at every minor adjustment. Let me instead show you a system that works in every situation and that will allow us to easily swap details around with just one click, all of this while tweaking the amount of available geometry to either get infinite details or nice and crisp close-ups, or both if your machine can handle. We will build this system in the most generic way, as to make it virtually reusable on any occasion. Okay, so here I am in Blender, and what is more generic than using a simple plane? Let's then hit Shift A and add a plane, tab into edit mode and rotate it by 90 degrees on the x-axis. And this is the kind of orientation that you want, with the positive z-axis all the way up. Remember as well every now and then to use the face orientation tool to check whether the normals are pointing the right way. Let me now show you a couple of examples on how we can build our patterns and make them ready to be baked into Substance Painter. As you will see, all the meshes used for this purpose have been designed in such a way that they are tileable, which means that by using arrays we can build consistent and seamless loops. These loops in turn will need to be placed properly on a base plane as to ensure that once turned into textures, this will result in something tileable as well. Okay, let's start from our first example, tab into edit mode and scale everything down a bit. I'm then going to enable the snapping tool and set it on Vertex, and in this way I can move my mesh toward the upper left corner of my base plane until it snaps into position. In order to get the same alignment also on the right side, it will be enough to add a mirror modifier and leverage on the fact that both the mesh and the base plane have their origin points right at the center of the 3D world. I will then add an array modifier on top of everything and start bringing the number of iterations up until I get a slide overlap. I will then enable the merge option and make it consistent with the size of our mesh. And at this point the trick would be to identify one of the leftmost vertices of our loop, shift and left click again to make this our active point. I will then switch the pivot point to active element, and this will allow us to scale up or down without losing our alignment with the base plane. I'm then going to scale up until I close the loop. And finally, all I need to do is to reposition the pattern on the y-axis until I'm satisfied with how much it is sticking out from the base plane. Speaking of which, I'm going to add a material, scroll down to the viewport display and choose a color in order to better visualize whether there is any unwanted compenetration between our base plane and the pattern we are building. Moving on to the second example, this is interesting because we have a mesh which is yes tileable, but in this case not symmetric, as the pattern is going from left to right. I'm going to repeat the same steps as before and see where we end up with. This time I'm going to align it to the bottom left corner of the base plane. Again, I'm going to use a mirror modifier and an array modifier on top. I'll then bring the number of iterations up until I get that slight overlap. Enable again the merge option and make it consistent with the size of our mesh. Finally, I will identify a valid active point, disable the snapping tool, scale down to create a little gap in the middle, and then scale up until we close the gap. This is the pattern we get. If you instead want the pattern to be, let's say, uniform from left to right, all you need to do is to delete the mirror modifier and double the number of iterations in your array modifier. And of course it is guaranteed that the pattern will end up right where it is meant to. I spent a bit of time to create some new patterns and to resize and reposition those we did together. Now, before moving on to Substance Painter, I want to point out that it is useful to plan ahead which kind of materials you'll be wanting to apply and to which portion of your patterns, in order to use the Vertex Paint tool to help yourself out later on in the process. In my case, I'm going to use a base marble or stone material, and I want some of these little details to be textured using a sort of gold painted material. I'm therefore selecting my pattern, tabbing into edit mode, and now I'm going to select all the portions that I want to texture using this second type of material. I'm then switching to the Vertex Paint mode. Click this icon here to display the selected vertices, choose a color, and then paint and set vertex color. I then repeated the process for all my other patterns, and now everything should be ready to be exported into Substance Painter. But before doing that, I'm going to give a quick check to the normals to see if everything is blue and fine. We can then select our base plane, go to File, Export, FBX, tick Selected Objects, and I'm going to call it _low since this will be our low poly object. I'm then going to select everything and again File, Export, FBX, Selected Objects, and this time I'm going to call it _high. I have my Substance Painter project open with my base plane loaded in. Remember to check under project configuration whether you're using the correct normal map format. I'm going to rename my material into something else and move on to the baker, which is essentially the place where all the maps based either on the geometry of our mesh or the combination of this one with whatever high poly object we specify will be printed out ready to be fed into our smart materials. We can import our high poly object by clicking on this icon and selecting the corresponding file. We need to increase the max frontal distance until every red spot disappears, and this is essentially the distance at which the software is shooting from our low poly object into our high poly mesh in order to look for details in excess to be printed on the mesh maps. I'm going to select the desired output resolution, and I'm also adding a bit of anti-aliasing as well. Under the ID map, change the color source from material color to vertex color, enable the height map too, and hit base selected textures and wait for the process to end. I'm back into painting mode and this is the result that we have so far. Now move to the library and switch over to project. Under texture you can find all the mesh maps which has just been baked. Look for the height map, right click and export resource. Now back to the library, I'm going to select my base marble material and apply to the mesh. I'm going as well to take my gold painted material and place it on top. I will then add a black mask and in the sublayer a color selection tool. With a color picker from the ID map, I'm going to select this yellow color, and now everything is ready to be exported back into Blender. To do so, let's go to File, Export Textures, choose a folder and a resolution. Under Output Templates, look for the PBR Metallic Roughness and remove the unnecessary maps, such as the emissive and the height map we just exported. Back to Settings, just click on Export. Before moving back into Blender, I'm going to create an additional material to be used on my final model on all those sections that will not contain any kind of decoration. I'm then going to rename my material into something else again. From the layer stack, I'll remove the gold painted material, and now back into the baker, I will just remove any high poly mesh and bake again. Finally, let's go again to File, Export Textures, and click on Export. I'm back again into Blender with my final mesh, which just consists of two simple profiles stacked on top of each other. Both have already been unwrapped, and since they are essentially flat planes with a bit of manipulation, no seams have been used. Despite this, if I open a new tab and switch over to the UV editor, I can still select whatever face I want and move it freely and separately from the rest. We will leverage upon this concept when playing around with UVs. I will focus first on this bottom mesh here, so let's click on it. I'm going to create a new material and call it Plane. I will then create a second material and I'm going to call it Detail. We can now load the textures we exported from Substance Painter in, so the plane textures for the plane material, and those containing all of our decorations for the detail material. Now the question will be, where do you want your decorations to be placed? In my case, I want to place something onto this face right here, so I'm going to click on it, then click on Detail, and Assign. Of course, we will need to do some UV manipulation, so I'm going to open a new panel and switch over to the UV editor. In my case, I want this kind of decoration to be placed right here, so I'll take my UV island and rotate it by -90 degrees. Under UV, there is a useful option, which is Constraint to Image Bounds, that will help us in repositioning our UV island, since our movements will be constrained to the UV space. I'm then going to position it as precisely as possible, and this is the result that I get. Now, since the width of this UV island is exactly the same of that of the UV space, it is guaranteed that it will tile correctly. To prove that, you can use an array modifier and see that this is working exactly as expected. For the second example, I'm going to take this face right here and I'm going to assign it to my detail material. Again, I'm going to rotate it by -90 degrees, and with the help of constraint to image bounds, I'm going to position it right where I want. As you can see, we will need to scale it down in order to make it fit properly, which means that we basically lost our one-to-one relationship between the width of our UV island and the width of the UV space, which in turn means that we cannot tell if this is going to tile the way we want. To fix this, I'm going to position my view right at the leftmost point of my mesh, and I'm going to enable the array modifier back. At this point, all I need to do is to scale down the UV island on the x-axis until I'm satisfied with the way it is tiling. Another useful technique we can use is stacking UVs, which means that we can identify portions on our mesh which are identical, like these two parts here I have selected, and we can avoid repeating the same operations multiple times by manipulating their UVs all at once. I'll select this second UV island right here, enable the snapping tool on Vertex, and I'm going to move it on top of the other until they completely overlap. I will then select them both by pressing A and assign them to my detail material. I can now rotate them by -90 degrees, enable again the constraint to image bounds, and finally position them on the type of decoration that I want to apply. We can now add the first layer of customization to our setup by using multiple UVs. In the Object Data Properties tab under UV Maps, all of our UV configurations are stored. We can add a new one by clicking the plus icon, and we can switch between the different configurations by clicking on this camera icon. Suppose now I want to change the type of decoration applied to this face. With my second UV selected, I can tab into edit mode, select this face, and move it over whatever other kind of decoration I want to apply. I'm going to rescale and reposition, and at this point you already know the steps to make this tileable again, so I'm not going to repeat them, but this is just to show you that we can easily switch between different configurations with just one click. I created some additional UV maps just to reinforce the concept, and even though you're limited to a maximum number of 8 UV maps total, this should still be enough to guarantee a decent amount of variation in your setups. Let's now introduce something a bit more advanced. I brought in my second mesh and I added my two materials, and also in this case I use multiple UVs in order to have the possibility of switching between different types of ornaments. But in this case, as you can see, the normal map that we are using is probably not enough in order to sell the effect that we want, as this type of details are supposed to be sticking out from the mesh a little bit more. What I'll do here is select my detail material, create a copy, and rename it. In the shader editor, I will then duplicate one of the image textures and use it to load in the height map we exported from Substance Painter. We'll need to change the color space from sRGB to linear. Take this green dot, drag and release, and look for displacement. We can now connect this displacement node to the displacement socket of our material output. I will bring the scale down to 0 for the moment, and now one important bit is in the material properties to scroll down and look for settings, and under displacement change from bump only to displacement and bump. To make these setups work properly, I'll then tab into edit mode and add a few edge loops. Of course, you can experiment and try to find the number of edge loops that works best for you. In my case, I'm just trying to keep my topology as uniform as possible. By playing around with the scale value of our displacement node, you can see that we are getting toward the desired result. But on a closer inspection, you can see as well that we have a few artifacts here and there, which depend on the fact that past a certain threshold, our displacement value will be too high compared to the amount of available geometry. This means that for distance shots, we could get away with low levels of displacement and no additional subdivisions, but as soon as we start getting closer and cranking the scale value up, we will definitely need those extra subdivisions in order for our mesh to look clean and sharp. Let's see how we can automate this process. The first step would be, with our mesh selected, to go under Object Properties, look for Custom Properties and click New. Click then this gear icon and let's rename our property to something like detail amount. I want it to be an integer with a default value of 0 and I want it to range from 0 to 3. At this point we can click OK and this newly created property will appear here in the side panel. We can now tie the number of subdivisions to whatever value our custom property has. To do so, I'm going to right-click here and copy data path. Then in our subdivision modifier, I'm going to right-click and add driver. This simply means that the number of subdivisions is going to be driven by something else. In particular, I want it to be driven by our single property, which belongs to our object called comp_1, and here under path I can simply hit Ctrl+V to paste the name of the property. What the software is going to do is going to take the value of our custom property and add 0, which is exactly what we want. We can then hit update dependencies and check whether everything is working as intended. Finally, I'm going to tie the number of subdivisions at render time as well, but in this case I want it to be one level higher than those we have in the viewport. So again, I'm going to right click, add driver, I'm going to select my single property and the object that has that property. And under path, I'm going to hit Ctrl+V to paste the name of the property. And in this case, I want the software to take the value of my custom property and add 1. We can then update dependencies. And as you can see, this is working exactly the way we want. The final step would be to tie the scale value of our displacement node to whatever value our custom property has. And in this case, I want the scale value to go up by 0.04 for every additional level of detail I type here. So again, I'm going to right click and add driver. Again, I'm going to select my single property, my object, and I'm going to paste the name of the property. 0.04 for every additional level of detail means that the software has to take the value of my custom property and divide it by 25. Again, update dependencies, and now our system should be complete. So let's test it out. We can start from 0, like for distance shots. Then we can close in and start increasing our detail amount, and you'll see that the scale is going up and the number of subdivision is doing its work. And then again all the way up to 3 in order to have nice and clean close-ups. Now the next logical step could be to tie the detail amount value right here to the distance between our object and whatever camera we are using for rendering purposes. And that would be as simple as adding a driver also to our custom property and playing around with the distance value. Now I will leave this up to you, and let's for now simply review what we have built so far. So what we ended up with is a flexible system where we can switch between different setups with just one click, leveraging upon the concept of multiple UVs. We then built an easily tweakable level of detail system that allows us to repurpose our mesh based on the kind of shot that we are trying to achieve. When it comes to rendering, and especially when you are heavily relying upon normal maps in your scene, it is essential to have a proper light setup. The tip here is to try and break the uniformity of how light rays are hitting the surface of your mesh, building up contrast and thus making your details pop out more. This can be done in a multitude of ways. You could do it either by manually placing so-called obstructors between your light source and your mesh, or by using pre-made professional resources called GOBOS. GOBOS are essentially lights with textures that will help you in this task. Additionally, they will add context to your scene, improving the overall realism. In the example you are seeing, I am using a pack nicely put together by the 3D artist Iva Salukvadze with 10 and counting 2K GOBOS, perfect for interior and exterior scenes. The pack is asset browser ready, which means that you can easily drag and drop the resources in your scene to test them out. In case you're interested, I will drop a link to this pack in the description, make sure to check it out. And that would be it for this video. I hope you learned something useful. Let me know what your thoughts are in the comment section down below, and see you next time.